Here we are still factoring and still trying to find the zeros and roots of polynomials. And we learned that sometimes we have complex roots. So if we have a polynomial here, q of x is x cubed minus 3x squared plus 3x minus 2, this would not factor by grouping. I could try, but it's still not going to actually factor by grouping. We are not given one of the zeros like we were last time. So we have to figure out what one of the zeros is. One way to do that is to graph the function. So I would typically just plug this into Desmos, see if we can find any of the zeros. And I've given you a graph so we can find that 2 is a 0. All right, so we can see that x equals 2 is a 0 of p of x. If x equals 2 is a 0, then x minus 2 is a factor. If we know a factor, then we can continue to find more factors by using division. So we start that long division process again. X minus 2 divides into our polynomial. We take that x minus 2, do the long division. If you need to go ahead and pause the video, you can go ahead and do that and then do that long division, or you can do it with me. Okay, so I end up with, x squared minus x plus 1. This does give me a remainder of 0, which we already knew should happen, but it helps me figure out that p of x could be written as x minus 2 times x squared minus x plus 1. That does not factor more. That's okay. This is an irreducible quadratic factor. We just have to figure out what are the directions in the question asking. And this one asks us to factor all the way into linear factors with complex coefficients. So we need to take this and find the roots. One of them we already know is going to be at 2. We were given that one. The other is coming from that irreducible quadratic factor. We're going to need to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So once I do that quadratic formula, we'll have the roots, the other two roots. We have a negative 3 inside of the square root in that quadratic formula. That negative 3 should signal that we have an imaginary root here at 1 plus or minus I square roots of 3 over 2. So the factored form p of x would look like x minus 2. One of the other factors would be x minus 1 plus I square roots of 3 over 2. And the other factor is x minus 1 minus I square roots of 3 over 2. That looks a little funkier because we had uglier roots. But that is a product of linear factors, and they do have complex coefficients. All right, so now the last section of this is writing that polynomial when we've been given the zeros. And we did this when we had nice integer zeros, but this time we don't have nice zeros the entire time. So I have r of x is degree 4, and it has zeros of 2 and 1 minus 3i. There really should be an extra part into this saying that the 0 of 2 has a multiplicity of 2. We could figure that out just by context clues, but that's a little harder. We know that there should be 4 zeros. One of them is imaginary. So there is a 0 of 1 minus 3i that's given to us. Because we have an imaginary root, it always comes in a pair, so there's also one at 1 plus 3i. It wasn't explicitly told to us, but it doesn't even have to be. I know that it has to have one at 1 plus 3i and another at 1 minus 3i. The only other way to get 4 roots here is if that 2 had a multiplicity of 2, because that 2 should be counted twice. And then I have one at the 1 minus 3i and another at 1 plus 3i. So I forgot to type this in the notes, but multiplicity of 2 here, and there are 4 zeros now. Given those zeros, we can write the factors that go with them. So r of x, in this case, would be an x minus 2 squared for the 0 at 2 with a multiplicity of 2. We also have x minus the root of 1 minus 3i and a factor of x minus 1 plus 3i. Notice that I'm putting that root in parentheses because I am subtracting the whole root. So if it was in that property part of the notes earlier, we had if a is a 0, then x minus a would be a factor. If 1 minus 3i is a 0, then x minus this 1 minus 3i is a factor. You could expand this out so that we get the irreducible quadratic factor. That's the goal, is that we're leaving our answer as a product of linear and irreducible quadratic factors. So I need to multiply these so that we can get the quadratic factor. This x minus 2 squared, that's a linear factor. It's just happening twice. It's got a multiplicity of 2. To expand this out, I'm going to need to do the subtraction inside that factor. And then we can distribute. So we're not distributing out all the way to standard form. We are only trying to get our irreducible quadratic factor. That's coming from this x minus 1 plus 3i times x minus 1 minus 3i part. This just takes a longer process. So x times x is x squared. X times negative 1 would be negative 1x. X times negative 3i is negative 3ix. And that's just distributing the x part. Then we distribute our negative 1. So we do negative 1 times x would be negative 1x. Negative 1 times negative 1 is positive 1. Negative 1 times negative 3i would be a positive 3i. Now we've distributed the negative 1. We then have to distribute the 3i. So I do 3i times x would be a positive or plus 3ix. 3i times negative 1 is negative 3i. And 3i times negative 3i is negative 9i squared. That's a long distributing process because we're doing a trinomial times a trinomial. but there should be some parts that will simplify down. So if I combine like terms, there's an x squared that can't combine with anything. And then we have a minus 1x and another minus 1x. So negative 1x would make negative 2x and minus 2x here. This negative 3ix has a positive 3ix that it can combine with to give me 0. There's a positive 1 here that doesn't have another thing to combine with. Then I see a positive 3i and a negative 3i that can combine to be 0. Lastly, we have this minus 9i squared. Remember that I squared is equal to negative 1. So that's truly saying negative 9 times negative 1, which would be positive 9. So instead I can put plus 9 there. And if I combine like terms one last time, we have our irreducible quadratic factor. So this one would be x squared minus 2x plus 10 as our irreducible quadratic. The x minus 2 squared is a linear factor. But now r of x has been written out as that product of linear and irreducible quadratic factors. There are two more examples here. R of x, in this case, is degree 3. It has zeros at negative 2 and 3 plus 2i. So we know that it should have 3 zeros. We've been given 2 of them. We have to figure out, well, where is the third one? So I want you to try to pause the video and use your skills to practice the last two examples. Your other has p of x is degree 5, and it has zeros of 4 with a multiplicity of 3 and 2i. That means that there should be 5 zeros, and we have to figure out what do we do based off that information. So go ahead and pause the video, and then you can check your answers. All right, so I already have this one worked out. This would be x minus 4 cubed times x squared plus 4. That's the product of linear and irreducible quadratic factors. And then I didn't actually work this one out yet, so you can work it out with me, or if you've already done it, you can fast forward to when we get to the end of it right here. What I would have done is take r of x, and I have a factor of negative 2. Sorry, a 0 of negative 2. So it has a factor of x plus 2. It has a 0 at 3 plus 2i, so there's a factor of x minus 3 plus 2i. And then we have x minus 3 minus 2i. That's where the third 0 came from, 3 minus 2i. It always comes in a conjugate pair. We could rewrite that as x plus 2 times x minus 3 minus 2i and x minus 3 plus 2i. We have to do the distributing. That distributing is going to take a while. And maybe you eventually figure out some shortcuts to do that. But for now, you just need to understand what's going on when you're distributing all that out. So after we've distributed, we're going to see some things that can combine and add to 0. And then there's other things that can just combine in general. We have x squared minus 6x plus 9, and then minus 4i squared. That minus 4i squared is negative 4 times negative 1, which is a positive 4. So r of x would be x plus 2 times x squared minus 6x plus 13. There's our linear and irreducible quadratic factor. All right, so hopefully you have practiced those, but if you need some extra practice, you can look through some of the examples in the textbook. There is something called the rational root theorem. We are not using that theorem. This one is a little bit outdated because we now have technology that does things for us that can help us find zeros. This is in chapter 3.5, but we are not doing this necessarily. So if you see things that are asking you to find the possible roots, that's what that textbook is doing. And then you're using division to kind of find out what the factors would be. I did add in an easier method to multiplying factors with complex conjugates. So when we had something like x minus 2 plus I and x minus 2 minus I, we could distribute this out a little bit differently. So I don't love the way that the text is, but it's just part of that process. So I'm just going to rewrite it down here. X minus 2 plus I times x minus 2 minus I. If you distributed that out, that would say x minus 2 minus I times x minus 2 plus I. And earlier, we just did the whole distributing that through trinomial times trinomial. But I could group this x minus 2 together. And these parentheses, now that we've done the distributing, aren't really doing anything. They're just showing this small group of x minus 2. But it helps me distribute this part. This would say x minus 2 times x minus 2, which is x minus 2 squared. Then we have x minus 2 times I, which would be plus I times x minus 2. And if I distribute the next part, it's negative I times x minus 2, so minus I x minus 2. And then the last part is I times I, so minus I squared. The nice thing about that is your x minus 2I, or I times x minus 2, and negative I times x minus 2 would add to 0. So we're really left with x minus 2 squared minus I squared. If you've been doing this binomial squared part for a while, since the beginning of class, you might be able to already know that's x squared minus 4x plus 4. And this minus I squared is minus negative 1. So that's x squared minus 4x plus 5. All right, and if that makes sense, that's great. If that doesn't make sense, that's okay. You can continue to distribute out the long way. Distributing out the long way was taking this trinomial times a trinomial and doing each individual part distributed out. All right, thanks for watching the video and taking notes. Hopefully that makes some sense. If not, ask me some questions. That's fine too.